Welcome to solverfy.
All right, so here we are writing an algorithm that will search for an element in a list by splitting the list into 4 sublists, but kind of over and over again, right? So we'll just call this quaternary. And so what we need in here is an integer that we are searching for, as well as the list that we are searching in. Okay, and the list should be non-empty. So the first thing we're going to do is set I equal to the leftmost element of the list, or the index of it, and j equal to the rightmost index element. And then while I is less than, and not just j, but j minus 2, and this is because we need to be able to split the list into 4 parts. And that is not possible if, say, the distance between them was only 2, right? That would give us only a couple parts to split it into. So we're making sure that we can split it into 4 elements here. Okay, and then we're going to set some variables equal to roughly the first quarter of the way through that difference. And so this is an L, and then we'll have an M, which will be the halfway point, and roughly. So we're using the floor in case it's not evenly divisible by 4, so that we get an integer, since we are finding index values here. And then we'll have a U as the next one, and this will be our 3/4 of the way through that list. Okay, and so essentially, if we have our list here, we've put, L about 1/4 of the way through, and then M about halfway through, and then U would be 3/4 of the way through. And so now we want to say, well, if the item we're searching for is greater than or equal to the element in the list at this 3/4 index, then we're going to reset our left searching index to U plus 1. Okay, and then the next one is going to be to compare it to AM. So if x is greater than or equal to a at the mth index, well, then we need to set I to the left side of this interval and j to the right side. So we're actually going to be setting 2 elements here. And so then we get I being equal to m plus 1, and j will set to u. Okay, and then similarly, we'll do the same thing for this next interval, right? So if, and I should be clear that this is going to be an else if, okay, so else if, so same thing. So if x is greater than or equal to a sub L, then we need to reset our search range so that I is going to be L plus 1, and J is equal to M. And then the final else case, we would not need to reset I for this the first quarter of the list, but we would just need to set J, and so then J would then be equal to L. Okay, and so then that would return, 1/4 chunk of the list, and then if that chunk of the list is larger than 4, it'll go through the loop again and split it up again, and eventually there should only be 3 elements remaining. And so then we're just going to parse through and compare our search element to all 3 of those. So we get out of the loop here, and then we leave myself enough room to sort of index left correctly. But so then we would say if X is going to be equal to a sub I, then we can set our location to I. All right, and then the same thing for the next index. So if X, and in this case, we could say either I plus 1 or J minus 1, really. This will be the same thing. And this should be an else if. So that's else if. Else if X is equal to A sub I plus 1, then we'll set the location to I plus 1. And lastly, just for the third remaining element, if X is equal to A sub J, then the location is equal to J. All right, and so the very last case would be if the element is not in the list. And so then we would set our location to 0. And finally, see if I have room here. Finally, we would want to return we'd want to return the location. All right, so we have some sort of output. All right, and that